Now that we know about atoms and bonding and covalent bonding and stuff like that, we need to talk about water. So our bodies are 60 to 70% water. So water's pretty important. So water is two hydrogens and an oxygen, the molecules, and they look a little bit like this. So an oxygen and two hydrogens. And they are covalently bonded. Okay, so they share electrons. So hydrogen has one electron. This hydrogen has one electron. Oxygen needs two, so oxygen shares hydrogen's one electrons with each of them. But you can see I drew it kind of weird. If I drew it like this, it would mean that the hydrogens, or excuse me, the electrons that are being shared would be being shared equally. They would go around and spend the same time with everybody. Just equally. So shared equally. So that is a covalent bond. That's called a non-polar covalent bond. And that just means, again, that the electrons are being shared equally. Well, water isn't like that. Water does not share its electrons equally. In fact, oxygen pigs those electrons most of the time. So the electrons spend most of their time up here and only a little bit over there. All right, so the electrons are not shared equally here. And this creates a polar covalent bond. And polar means, if I redraw this, you've got your oxygen, hydrogen, hydrogen here. You know, the electrons are negative. So if they're spending more time over at oxygen, so they're closer to here, then that's going to make oxygen kind of negative. And since the electrons aren't near the hydrogens very much, it's going to make the hydrogens kind of positive. So it makes sort of a negative pole and a positive pole. And this polar condition that water molecules have makes it able to have the characteristics that water has. So water molecules basically stick together. So here's a water molecule, and this is a little bit negative, this is a little bit positive. Here's a molecule, a little bit positive here, a little bit negative, and so on. And we know that positives and negatives attract one another. So these poles are attracted to each other. And that's what holds water together. So we'll put this here. Do positive, negative. And again, this is going to be attracted there. Okay, this is attracted here. Okay, so there's all kinds of attractions going on that hold those water molecules together. These attractions are called bonds, but they're not true bonds. They're called hydrogen bonds. And we're going to see these a lot, and that's what holds these water molecules together, is these sticky hydrogen bonds. Hydrogen bonds between water molecules create surface tension. So surface tension comes from these little molecules being held together by these bonds, and it allows for things like the water beading on your windshield. If it beads up, that's how it keeps it together. You see little bugs that can float, like sit directly on the water. It's because they're not too heavy and they don't break those hydrogen bonds. We can't do that because we're too heavy, and as soon as we get in the water, we break those bonds. They're easily broken because they're not really bonds. They're just attractions. So that's where surface tension comes from. So the great thing about that is it adds to a lot of the characteristics that water has in our body. Water is a great solvent, okay? So water is a good solvent. And that's due to these hydrogen bonds, because they can break apart stuff through that stickiness. If you put salt into water, then the sodium is going to be attracted to the oxygens, and the chlorine is going to be attracted to the hydrogens, and it's going to break that salt up. So it's going to dissolve in water. So that makes it a great solvent. What else do I want to say? So in the next video, we're going to talk about the properties or the characteristics of water. And a lot of those characteristics are a result from the fact that water is a polar molecule. So don't forget that water is a polar molecule and what that means.